Alrighty, here we are. This is going to be the first video I'm going to show on trying to use Xcode with our CMake-based projects. So to begin with, I'm going to use some of the GitHub command line tools. So if you have not installed those, you may want to visit this page right here, macappstore.org/gh, and it gives you a quick and easy way to install the GitHub command line client on your Mac. This assumes that you have Homebrew installed, so you'll be using Brew to actually install this using these instructions. Alright, the other thing is I'm going to work with Lab01. This is my student version of Lab01, so I'm going to replicate what you have going on here. And secondly, we'll use CMake from the command line to generate the Xcode projects. So if you don't have CMake installed, you can either do that with Brew, or you can download the source right here. Just go to cmake.org/download and look for your platform. Depending on what version of Mac OS you have, go ahead and just download the DMG file, and you can use that to install CMake quite easily. So assuming you have all those things in place, and obviously Xcode installed, this is not just the simple command line tools, this is the full-blown Xcode product. So that's what I'm assuming here. So anyways, I'm going to close this and come back here, and again, I'm going to use the command line client here, and so I'll just copy this version of the clone command, and I'm going to go into my CSC232 directory that I've created for the class, and I'll just do this command. And by the way, I'm working on a terminal window here, and so I'm doing GH, that's GitHub repo clone. The organization is MSU-CSC232-SP22, and the repo I want is Lab01-JDing. If you have not done this yet, you'll be prompted to authorize your login to GitHub first. That's just GH space auth space login. You'll be told what to do if that happens. At any rate, I've cloned this now, so I'm going to go in here to this directory, and if I take a look at these files, this is what is on the trunk branch when you clone this. So the first thing I'm going to do is actually check out my develop branch. So I'll do git checkout develop. Oops, I haven't done this yet, so I need to -b develop. And now I'm on my develop branch, and now I want to generate the Xcode project files. So I'm going to use CMake to do this. So I'm just going to type CMake and -s for the source of the CMake list file. That's the current directory. -b to tell it where to put the build files. I'm just going to create a directory called build, and then -g, and I'm going to tell it to use the Xcode generator. So this will generate an Xcode project in the build folder for us to play with. Alright, this is taking a little bit longer than I'm expecting. Okay, here we go. Could be that I have Homebrew installing some other upgrades right now. Anyways, so this is all done. The build files have been placed in the build folder, and if I do another listing, you'll notice I now have a build folder as well. So I'll go into the build folder, and if I look here, sure enough, I have an Xcode project file. All right, so Let me just open up this folder so that I can just double click on this and have it open in Xcode. There we go. My computer is definitely running slow today. And you see here that we have a bunch of files. Now I'm going to make some changes to the standard configuration here to make this a little bit easier to work with. So to begin with, let's see how we select our targets in Xcode. So the target can be selected right from the top here. And you see I've got a Lab01 target, I've got a demo target, I've got Lab01 test target. Those are the three that are going to be of interest to you. Some of these others are there by default. I won't worry about them right now. At any rate, if I try to run the Lab01 target, if I click this button, I'm going to go ahead and it'll build it. And we say, oh dear, it has failed on us. So let's see what's wrong here. And it's telling us that it's expecting a semicolon at the end of the line here. Now, this source code is just fine. What's the problem is that this is using a modern syntax, namely the standard initializer that comes with C++ 11 and later. And CMake does not seem to know which version of G++ to be using or what version of C++ to be using. So that's one of the first things we're going to actually change here. So if I come back here to the folder view and double click on the CMake list text file, I'm going to have to say something about that. And so if I recall, we can do it one of two places. We can either update the CMake list text file or we can update the project settings. So let me see what about that I can do. And so here, let's see, are there any options here? No, I'm sorry, this is not where I want to look. I want to look actually at the project. And I'm going to look at my build settings. And let's see here. I can do some C++ flags here. Let's try this here. So for our debug, let's try what is a C++ standard equal C++ 11. And let's try building that again. And we still get a build field. All right, this is not the way to go. Let's try this on the Lab01 version. And let's try building that one more time. And now we get a build succeed. So the best thing to do is for your targets, and what I've done here is on the folder view, I've clicked on the top level project and I've gone to build settings, and I am looking down here at the Apple CLang custom compiler flags. Let's see, I wonder if I could have done that here. Ah, yes, this would probably be a better way to do it. I'm just going to get rid of this, and I'm going to come down here to choosing C++11. That should also work. So I'm rebuilding. It builds again, but now we're getting this issue about could not open main data.txt. And the reason for this is that it's actually, Xcode is actually putting things in a debug folder. So if I look here, for example, if I go into the build folder and I look what's here, oops, not build, just into the build folder, I see that there's this debug folder. And in the debug folder, I see that's where my target was created, that Lab01 target. And it's looking for that main data.txt file, but I can't find it in this folder. That's because that file is actually here in the build folder, not the build/debug folder. So what we can do is we can set the working directory for our build in another setting here. So let's go to Lab01, edit scheme, and for our options, we want to set a custom working directory, and that should be right here where the main.data.txt folder is located. So I'm just going to copy the name of this folder, and I'm going to place it in that setting right there. Now, when I run this, we see that it has successfully opened this file. And so here's the state at which you can be working. So these kinds of things are target specific. So I would do the same thing for Lab01 demo. If I wanted to modify this target, I could still change the compiler language dialect to be C++11, and I can set the scheme for the Lab01 demo. Similarly, under run, I want to use that same custom directory. All right, and then might as well do that for the tests folder as well, or the test target. Go to run, and then set custom working directory to be our build directory, and hit close. And so now for each of these targets, right, I'm going to have these changes. And so now, regardless of what target I'm choosing to run, like here I'll do the Lab01 demo. This should build now just as equally as well, and it's reading the demo text. And then if I have unit tests created for a project, they'll be in the assignments tests target. If I run this, for example, we see the output down here. And there you go. So now, what about working with other files? All right, so here's where it can get a little tricky. So right now, the only source files that we see are the ones that are associated with these specific targets. And I want to work on a new thing here. So I'm going to do something different here. I'm going to go to the command line really quick. Or no, I'm sorry. Yeah, let's go to the command line first. Let's go back into our source folder, which is where we're instructed to work. Again, I'm in my source folder, basically where these other two files are right now. And I'm just going to quickly just create a blank file here, an empty file to work with, and I'll do that with a touch command, touch array.cpp. And so now I have a new CPP file in here, and now I'll come to the CMake list text file. I can pick anyway. You'll see this in each of the targets. It's the same file. It doesn't matter. It's just referencing the CMake list text file that was used to generate that target. And I want to create a new target. So I'm going to create a new source set. So I'll say set source, oops, let's call it arrays or array files. And this will be the array.cpp file. And now I want to create a new target, so I'll say add executable and call this arrays. And I'm going to use the source array files variable that I just created. So now I'm going to have to rerun CMake. All right. So let me go back up above to the root directory. And first thing I want to do is I want to remove this cached file that CMake uses so that I can basically effectively rerun CMake on and get this new target. And so I'm going to remove from the build folder CMake cache.txt. And now I can do my CMake command again. And now I look here, and in fact I have a new target. And it doesn't quite know what's going on with this because there's nothing there. So here we can go ahead and do our stub. I think it was pound include C standard lib. And then we had int main and just return exit success. Excellent. So now I can try to run this target. So I'll pick the arrays target and I'll run that. And of course there's no output, right? I mean, there's nothing to see. So, but the program did end with Xcode 0, which is a good thing. And so here you go. Now you can just start making your edits to your files as you see fit. Just so you can see some output. You're not instructed in the lab to do this, but I'm just showing you this so you see what the output looks like if and when it does come up. So I have new stuff here. Go ahead and run this again. And so now you see the output that I just stated right here. And from here on, you can carry on. So I do have a change. You can see that as shown here, but the little M's here. This question mark is that it doesn't know about the status as far as Git goes. So under source control, I can commit my changes. And it's got one thing that's staged. I want to stage this one as well, so I'll put this here. And then I need a commit message, initial import of array stub. array program stub. And I can also choose to push to the remote right away, and it'll create the develop branch for me. And voila, commit and push. And things look pretty good so far. If I go back to GitHub, I should see a new branch. Here it is. That means I can create a pull request, create a new pull request, seek to merge develop into trunk, and here are the changes I made. All right, so I've added a new target to my CMake-based text file, and I've created a new array.cpp. So I can go ahead and create this pull request, call this Lab01. Reviewers, you should choose your teacher. He's not showing up here, or one of the GAs. All right, so don't know if I can choose more than one or not. Nope, looks like I can only choose one. So doesn't really matter here. Assign yourself this pull request. The label I'll use here is I don't know. Doesn't really matter here. An enhancement, whatever you want to do, it doesn't matter. And let's see, is there any projects I can choose? Yeah, it's a lab. I don't know if you'll have that available to you or not. Milestone, no milestone setup. So anyways, that's just extra goodies to put on there. Create your pull request, and now you see the actual pull request where people can make changes or comments and approvals. Please don't merge until you have received an approval from either myself or from one of the GAs.